So whether you are living in a big city or just visiting them, finding a specific location can be challenged, especially when you get closer to the destination. So, for example, when you get off the train or subway, it's very easy to feel lost. And in that time, campus in your Maps app does not offer much help. So Google published its AR solution. And so this solution is an integrated AR mode walking navigation. It helps you to point the way with AR signs, AR arrows. Huawei also published its AR map in this April. It shows the indoor route with the flowers. As you can see, unlike the Google map, it could show the route with the dynamic flowers route and combined with the arrows. It also can enhance the real world with colorful signs. So what's the AR and GIS technology architecture? At first, we have to know the supporting technology AR and AI. So first, AR core, AR key events. So they are AR foundation, AR core on Android, AR kit on iOS. It allows you to work with AR platforms in multi-platform way. And events is a multi-sensor state estimator, which can realize the accurate self-localization of AR application. And OpenCV, the open source computer vision library, which provides a rich algorithm to recognize and process images and videos. SNAP and IMU as the basis of the AR positioning provide accurate positions of AR application, and AI, a TensorFlow library, provides rich machine learning algorithm. So with this supporting technology, here are four main key technologies of AR and GIS. First is AR map, AR survey, then AR positioning or AR analysis. And SuperMap GIS 10i platform supports of these four key technologies and could develop the industry applications of AR and GIS based on these technologies. The first one is, so let's talk about this key technologies detailedly. The first one is AR map. Actually, this is a road I walk every day between company and home, but it's a little bit different. It's with the thing that I see every day. Can you recognize it? You can, as you can see, the buildings are not exactly existing here right now. But in your first view, you could not recognize it's a virtual building. So what is the AR map? Academically, AR map that enables real-time geographic information visualization and intelligent spatial analysis, which is based on the spatialization of video and utilize the computer vision technology and integrate virtual and reality. So it sounds like very abstract, right? But here, and next I will show you rich videos to explain what is AR map. First is the AR indoor map. When we visit a shopping mall, there are so many diverse shops. You will cost a lot of time to visit these shops, but with this AR map, you could check every shop in your phone before you go inside and to check whether there are some you're interested items that you want to buy, or then you can check your favorite items information then you can decide whether it deserves your visit. And for the outdoor map, it's not only can guide you to the destination, also can show you the shop's information and see the comments of each shop and the rank on in social media. And here's another project called AR Library. It's a real project. In this AR library, then you don't have to cost too much time on finding where it is. Using this application could show you a route to the specified book, and you could check the book's information on this application and see the comments and the rank in social media. Not only the traditional maps, but also you can integrate it with BIM models. So in this application, BIM pipeline model could project with the reality, so you can see what's inside the wall. And not only indoor pipeline, same as the outdoor pipeline. When we get real-time GPS coordinates of the pipelines, then we could match with the models with the real streets. And the pipeline also can match with the ground seamlessly. You could adjust the height of the models and to see the distribution of the pipelines across the streets. And here is a AR sandbox template. Through the camera of your mobile phone or tablet, the visitors can aim at the sensing point of the camera on the ground or the wall. Then the 3D terrain and the landfall or images could be displayed on the screen. And here is a project for AR for residential information. And in this application, of the buildings not only displayed in the screen, and the residential information can be displayed. The number of families and the residents, and you can see different colors represent a different group. Elder people or teenager people, that groups should be taken care of. AR also could attach with the POI. Then in this application, we could see the distance to each POI. Not only in mobile site, a desktop also could support AR functions. Like say in this iDesktop, we could support adding the vector data and calculate the objects. Yeah, we could. Okay. And he also could, the AR map could be applied for drone flying. When we fly the drone, we also could attach a 3D building models, then attach other attributes information with this model. And during the flight, we could check each building's information. Next topic is AR surveying. This is a traditional surveying method. We could measure the height, angle, or distance. But there is a problem. There are two problems actually. The first problem is that these equipment are too expensive. We want to do the surveying job, so we have to cost so much on these equipment. And second problem, they're too heavy. When we do the field working, we have to carry a lot of equipment that cost our energy. So to solve these two problems, AR measurement could give you the chance to do some simple surveying works like say this is an example for measurement for tree diameters, and you can see it can measure the tree diameters accurately. And the second is to measure the height of the tree. And even though you didn't draw a straight line, but you also the system could correct the height automatically. So that's the area measurement. We could calculate the ground surface area and the building side surface area. Sometimes we need to do some census job. So for this, we could draw the outline of the buildings and attach the building and record the building information for each outline. And our mobile phone are equipped with SLAM that can collect the point cloud data. So with this technology, our mobile phone could collect the point cloud data of the buildings, then construct the room models. And this for some indoor surveying job with AR technology. You don't have to carry a lot of instruments. Here, you just need to use your phone. Take your phone and walk around with the objects. Then you got the result. Same as for outdoor AR survey, you will get the boundary of this building, and you can see the result could match with the reality accurately. So iDesktop also support AR measurement. You could measure the height and distance in the videos. So the third part is AR positioning. Unlike the outdoor positioning, which could rely on GPS, but GPS does not always work inside the buildings as a complex structure of the buildings. So we have to rely on other indoor positioning technology. The traditional indoor positioning technology includes the Wi-Fi, Bluetooth, or UWB. The advantage is obvious. They could provide stable signal and achieve high accuracy of the positions inside the buildings. But the disadvantage is also obvious. Like say, we have to cost on the hardwares, and the deployment plan is very expensive. Like for example, this is a UWB deployment. We have to ensure that a deploy plan could cover every corner of the buildings. Then we have to buy this, install these hardwares. So a perfect deployed plan should be examined several times, and so that it's complex of job and expensive. So what AR could help in this indoor positioning? Actually, we could use the SNAM and MU positioning system that our current smart mobile phone well equipped with these two systems, SNAM and MU. So with the integration and SNAM and MU, and with the help of multi-sensors, scalable deep camera, and scalable support for laser stem of our smartphone, we could achieve AR positioning. It's very easy to use and has rich texture and could achieve position relation. let's say the accuracy of the AR SNAM and MU. We walk around this building, then we got a track. They can match with the indoor map closely. This is the indoor AR vision positioning system. This new technology can use the user's phone camera to spot your surroundings and visually converse your directions right in front of your eyes. So how visual positioning system works? So a monitor and the IMU are its heart. Using the data from these devices, the world will be started and measured and identified. If you relay a mapped location, visual positioning system use your device's camera to analyze the surroundings where you are in. The greater accuracy of the features make it really easy for them to identify where you are. Here is a comparison for positioning methods. We can see the traditional positioning system could achieve a good accuracy, but the cost is very high. And with this AR positioning technology like SNAM and EU or vision positioning technology, we don't need to cost too much, but we also get same qualities of accuracy. And please note that Super Map supports all the positioning methods above. So you could choose Super Map products according to your requirements. And let's say some cases about the indoor AR navigation. And here is the indoor AR navigation. It could show you the route to the destination with the AR signs, and also it can integrate with outdoor navigation when walking in outside. It also could provide signs when we enter buildings. It can switch to the indoor navigation automatically. In addition, for the indoor navigation, could see the clear signs for the cross-floor navigation. Last part is about the AR analysis. So what is the AR analysis? When we get the AR recognized results, and with the combination of AR and GIS, we could extract useful information through the recognized object. First one is stereo recognition. Unlike to the traditional object recognition, we could with the stereo recognition, we could get the width and volume of this object. Like say this chair, we could see its width and height and the volume. Let's say this video. So we could get the videos across the street. The module can project the videos view on the street, on the road. Then, most important, we could detect the objects, the cars, and highlight the important objects. And here is the AR geofence in iDesktop X. In this video, we can see that the cars are marked with different colors. Different types of cars are marked in different colors. Most important, with the geofence technology, the traffic violation will be detected. So that's a detailed explanations for 4 key technologies of AR and GIS. Here is a summary. So for the camera, we are not only supporting for not applied with phone camera. We also can apply this technology with fixed camera or drone camera, and we got known the supporting AR technology, and most about the applications of each K technology, what we can do with these K technologies. And as we know, our mobile product, SuperMap iMobile and iTablet, could provide the functions for AR, but SuperMap iObjects or iDesktop X also could reach applications, AR functions. So we could develop many AR and GIS industry application